Welcome to Optimization Theory with Hash Frank. In this video, we will explore the exhaustive search method. This method will result in an optimum range within which our optimum point may lie. So this will not give the optimum correct points, but what it can do, it can give us a range within which we can say our optimum points will lie within those ranges. Now consider a unimodal function like this in our case, and take 3 points. This is the first step in our method. Now consider 3 points, and now what we have to do is we have to evaluate those function values given in the red and find those values, that is f of x1, f of x2 and f of x3, and do a comparison between those values. Now by looking at that graph, we can infer that the function value at x1 is the highest, followed by x2 and x3. So we can understand and come to a conclusion here. We can say if we go in the direction of point x3, we can reach the minimum point or the crater of this function. So by knowing that direction, we have to update the points, the next point, and then it will result in like this. So we will consider new set of points x1, x2, x3, which are updated points, updated by a distance del x. Now del x, it is a choice that we have to make based on our problem. The smaller the del x, the better the accuracy. So after that, the same method follows. We have to evaluate the function at this point and make a comparison. Again, from the graph, we can infer that the function value at x1 is the greatest. And so again, if we go down in the direction of x3, we can find the minimum point. Now if we do this step for repeated amount of time, we will reach a particular time when our function value will reach here, at least here. These 3 points will come and reach here, and that is those time that when we can say we're almost there. So when we reach that point, which is like this, we have to do the same function evaluation. And when we evaluate, we can understand clearly that the function value at x1 is greater than the function value at x2. Also, the function value at x2 is smaller than the function value of x3. Now we can see that that value at x2 is smaller than both x1 and x3. So that means within this range, that is from x1 to x3, this is where our minimum point may lie. And we cannot say x2 is the minimum point, but what we can say is x1 to x3. This is the range within which we can expect our minimum to lie. If we reduce this distance, that is distance from x1 to x2, which is called the del x, if we can reduce that distance, we can find exactly, accurately, which that point is. But from the law, we know continuous functions are divisible million times up to infinite times, and therefore we cannot really say at which particular correct point that our optimum may lie for a continuous function. So with this, we're concluding this method. Thank you for watching.